Now, to take an example, we know that UK SIP 9 gives us some fairly good spatially referenced data on temperature and precipitation. And for an industry like agriculture, this is crucial information in terms of adaptation. So when it comes to good and bad news stories, yes, there are bad news stories in terms of extreme events, but there are also good news stories in terms of Scottish ability to actually harness temperature changes and introduce novel crops, although there is a question about how much we want to publicise that message in terms of affecting wider behavioural change in society. So the UK SIP 9 is obviously an important database. It allows us to start a research chain in terms of understanding downscaled information and adaptation, but UK SIP 9 is overlaid on a lot more other global challenges which are important to Scotland. So there's the Royal Society report, there's reports on farming and food security. And these beg wider questions about how we adapt to not just internally, given the information UK SIP 9 gives us, but also where is our position globally on food security. And an interesting question is that if there are temperature shifts and if there are stressed parts of the planet agriculturally, and we are actually warming up and have an advantageous climate for growing new and novel crops, how do we position ourselves in terms of market demand? So the research that's going on within the collective, and undoubtedly outside of the collective, is using SIP 9 downscale to understand impacts of plants, animals, pests, diseases, biodiversity, forestry, transport, housing across the board. And there are a vast amount of research projects being undertaken using that data and trying to understand the costs and benefits of warming. A good example is work by colleagues in the Crop and Soils Division at SOC using basic biophysical models, which are often driven by, among other things, climate parameters, which deliver outputs in terms of crop production. And what these give us is some very interesting information in terms of, well, if we change the climate parameter, what can we expect in terms of the outcome for production of crops and livestock? And what we see are very interesting messages from specific research we've done undertaking the DEFRA, downscaling some of this information on the impacts of livestock and their exposure to disease and growing periods for grazing and what that actually means. Now, it's interesting to note that research in this area is in some ways running behind the policy environment. It seems to me that we have some very interesting and ambitious policy frameworks, including the Scottish Climate Change Act, which has got very ambitious targets, and sometimes we are not altogether sure how the research is tooled up to be able to deliver on some of the promises made in some of this legislation. But we know that the research sets, that the policy documents set a very, very interesting and challenging research agenda. So, for example, the mitigation objectives we have nationally are almost akin to decarbonising our economy. And this does raise interesting challenges for research. Can we do this? Is it possible to deliver this within the time horizons set by government? But it's a great challenge, and if it runs ahead of research, then researchers have an obligation to try and catch up with it. So mitigation, and also the institutions that go with mitigation, have really set an agenda for research, which is unprecedented in many ways. So this is the portal or the webpage for the Committee on Climate Change, which has been set up after the UK Climate Change Act, and has set a very ambitious target of delivering mitigation across different sectors of the economy, and asking very blunt questions about how do we do this, how do you do it in transport, how do you do it in agriculture. What does the science tell us? And we've done a bit of work for them to try and understand the mitigation potential within forestry and agriculture, and often found that they're asking questions that the science doesn't have answers to, which is really, really interesting, Put science on the back foot somewhat, but also asks us to commit to be more definitive about our answers. We don't know is not an answer when you've got a policy decision to take. So what's the best that science can do for us? So this particular slide summarises the sectors that the Committee on Climate Change have analysed in terms of their mitigation potential using this device called the marginal abatement cost curve. In other words, just asking where can you mitigate most cheaply. We did a bit of work for them using this device to try and understand, and it's basically a bar chart, what measures are cheap to implement, what measures are a bit more expensive to implement, and what measures are just too prohibitive to implement at this point in time. or which can be improved with further research. And doing this for agriculture was a real eye-opener and a real basis for cross-disciplinary research, in the sense that it made us all think, not just within SAC, but within some of our partner institutes, Macaulay as was, and the Forestry Commission of Forestry Research as was, and partners down south such as ADAS. What are the mitigation technologies in agriculture, and how well do they work, and what do they cost to implement? And what you found is that there are as many things you didn't know as things you did. What it did do is make us drill down into specific measures. So looking at greenhouse gas emissions from the dairy sector, there are various points of intervention to understand emissions and understand what we could do over a relevant time horizon for the committee, such as improving genetics, such as looking at cows within their system, or looking beyond the farm system to the supply chain itself to understand where the balance of emissions actually were. And that's the beauty of that approach. It makes you focus on each technology and the understanding behind the science for each technology. I'm drawing to a close now, but I suppose what I should say is that as well as the targets and the research challenges that have been laid out for us, there are still lots of things we still don't know. So mitigation, it seems to me, has been, we've been given a metric. It's fairly unambiguous what we've got to do as scientists. There's some social science to understand the efficiency and the equity of doing that stuff. Is it fair to do some of this stuff? But when it comes to adaptation, we're really on more shaky ground. As you'll see here, I've tried to summarise the fact that there are no clear targets, no agreed strategies, no agreed metrics. The decisions have got to be taken locally and regionally, and this makes this a much more fluid situation, a much more challenging one in terms of institutions, governance, delivery and behaviours. I'll end with the two challenges, because I think we've asked three challenges, but I've only found two. There are many challenges implicit in what I've been talking about already. But the two challenges I guess I'll leave us with are, well, can be bracketed underneath the thing that's likely to drop off the science agenda, which is human behaviour, behavioural change. What instruments and incentives are there to affect behavioural change in terms of mitigation and adaptation? And are we counting the right things? I think there is a general recognition that we're focusing very much on the production side when we're accounting for our impacts, but is this a consumption side issue? I think there are a lot of people out there now asking this question about whether this is a consumption problem as much as it is a production problem. So I'll stop there. Thanks very much.